Alright, so balancing and writing net ionic equations. Number 5 starts from the word equation. So when you start from the word equation, the first thing you're going to need to do is identify the ions that are involved. So ammonium, hopefully you're starting to memorize these. Ammonium is NH4 and it has a charge of positive 1. Phosphate is PO4 and it has a charge of minus 3. So your formula for ammonium phosphate should be NH4. You need 3 positive 1s to balance out 1 negative 3, and then that would be aqueous or aqueous, depending on how you pronounce it. Alright, so then you've got zinc nitrate. Zinc is plus 2. And the nitrate ion is minus 1, so we're combining zinc at plus 2. Nitrate is NO3 minus 1. And so you need 2 nitrates and 1 zinc. So zinc is here. The nitrate ion goes in parentheses and subscript 2. Then what's that going to produce? Oh, this is also aqueous. Then what you need to know is what was at the beginning of the worksheet is that these are double replacement reactions. If they are double replacement reactions, then you got to follow the solubility rules that I gave you, and they are right here. Most nitrates are soluble, so if the ammonium trades places with the zinc, then one of your products is going to be ammonium nitrate. Since they are both, one is plus 1, the other one is minus 1, you only need one of each and no parentheses needed. One of the rules for solubility is that nitrate salts are soluble and most salts of ammonium are soluble as well. And so you know that this is soluble, so you put an AQ here. Then the zinc is going to trade places with the phosphate. Zinc is plus 2, the phosphate is minus 3. So you're going to need 3 zinc ions to go with 2 phosphate ions. And if you consult your solubility rules, most sulfides, carbonates, and phosphate salts are only slightly soluble, so zinc phosphate is going to be a solid. Then, next step, balance the equation. In a lot of cases, like the one we did for a warm-up, the ions stay the same, so it's easier to balance the ions rather than to balance individual elements. So if we try to balance, for example, the nitrate, the ammonium ion, we need 3 of those, but you can also see how you need 2 nitrates, and if you put a 3 in front of here, you're going to get 3 nitrates instead. Here, though, you've got 3 zinc, so maybe start by balancing the zinc on the reactant side and put a 3 in front of the zinc. That then gives you 6 nitrates overall, 3 times 2, so you end up putting a 6 here. Then your phosphates need to be balanced. And in order to balance your phosphates, you need 2 phosphates. It just so happens that putting a 2 here, wow, isn't that magical? You get 6 ammoniums, and you get your 2 phosphates, and then your equation is balanced.
Wait, doesn't, oh, never mind, I'm stupid. I thought that gave you...
No, don't say you're stupid.
Well, I thought that gave you like 8
Not allowed.
nitrates. Because I saw this that it wasn't completing for a second.
Yeah, all right, so next step, write everything out that is aqueous as ions, and so you're writing your complete ionic equation. So I'll do that down here, and so we're going to bust this up. You've got 2 times 3 is 6 NH4 plus aqueous, plus 2 times 1 is 2 PO4 3 minus, also aqueous, plus 3 times 1 is 3 zinc ions, plus 3 times 2 is 6, that's also aqueous. I get tired of writing the little parentheses aqueous, but I should do that. And then plus 6 nitrate ions, also aqueous. And then that's going to make our 6 ammonium ions again, 6NH4 plus 6 nitrates, and then it's also going to make our product, which is the zinc phosphate, which is solid. Next step, cross out the things that are the same on both sides. Get a different colored pen for that. So you've got 6 ammonium ions and 6 ammonium ions. You've got 6 nitrate ions and 6 nitrate ions, and what you're left with are the ions that make the solid product. Or it could make water, or it could make a gas, depending on the equation that you're dealing with. So rewrite it by convention, write the cation first. So 3 zinc ions plus 2 phosphate ions make solid zinc phosphate. And if you want to put the little aqueous signs next to your reactants, you can. And that would be your net ionic equation. Some of you are starting to put together, like Ronan came in and note for the warm-up today, was able to just go from the balanced equation to the net ionic equation. Once you get used to just writing down the products, you can do that.